Chapter 7.1, Apply the Pythagorean Theorem. So just a quick reminder for the Pythagorean Theorem, we use these in right triangles, and you can see the right angle right here. And if you go to the right angle and go across from the right angle to the side, that side across from the right angle is always going to be called the hypotenuse. Okay, the other two sides that are not the hypotenuse, those are just called legs. So if you recall the Pythagorean theorem, a squared plus b squared equals c squared. And a and b are the legs. It doesn't matter which is which, but if you go across from the right angle, that's your hypotenuse, and the side length c, that is always going to be your hypotenuse. So you always have to use c for the side across from the right angle. But a and b are the legs. It doesn't matter which is which. So this right here is the formula for the Pythagorean theorem. And c, a, and b, those are the side lengths of the triangle. Example 1, find the length of the hypotenuse of the right triangle. Okay, let's just go right to the diagram. So here is our right triangle. We're going to use a squared plus b squared equals c squared. Okay, see if you can solve this one, please. So recall, we said you go across from your right angle to the side, and that is always your hypotenuse. So I am going to let x equal c. The other two sides, it doesn't matter. It doesn't matter which one is a and which one is b. So I'm going to let a equal 8. And I'm going to let b equal 6. And of course, we can use our formula now. A squared is going to be 8 squared. B squared is going to be 6 squared. And c squared is going to be x squared. All right, the opposite of squaring something, the way to undo something squared is to take the square root of both sides. Now, you can do one of two things. You can finish this if you want to, or you can just take the square root right here. I'll finish it for now, but then I'll show you the shortcut. 8 squared is 64. 6 squared is 36. And that equals x squared. And of course, adding these two, that's just 100. Okay, and the opposite of squaring something is to take the square root. You want to do the square root on both sides. Now, in algebra, when you do the square root of both sides, you have to do plus minus. However, we are dealing with side lengths. There are no negative side lengths, so you just keep the positive, and the square root of 100 is just 10. The square root of x squared is just x. So that's your final answer. Okay, so negative 10 would not work because side lengths are not negative. Now the shortcut, you can work on the square root on both sides right here. If you do the square root of x squared, you would just get x. And if you did the square root of this right here, you would just get 10. Okay, so you don't necessarily have to multiply and square it and add it up if you don't want to. You can do it the quick way if you like. All right, please pause and see if you can do number 1 real quick. It should be pretty simple. All right, we have our right angle. Across from the right angle, we have a side length of 5. That must be the value for c across from the right angle. So c squared is going to be 5 squared. The other two sides are a and b. It doesn't matter which is which. I'm going to let a equal x, and I will let 3 equal the b. A squared is going to be x squared. b squared is going to be 3 squared. Okay, the shortcut would just be minus 3 squared on both sides, but I'll multiply it out. X squared, 3 squared is 9, 5 squared is 25. Okay, the opposite of plus 9, we're looking to solve for x. The opposite of plus 9 is minus 9. Cancels there. Bring down your x squared, and 25 minus 9 is 16. All right, the opposite of squaring something is to take the square root. You do that to both sides, and the square root of 16 is just 4. If you wanted to do the shortcut, in my opinion, if you kept it, instead of positive 3 squared, you would do negative 3 squared. On both sides, it would cancel here. And then you take the square root of x squared and the square root of 5 squared minus 3 squared. You could let the calculator do the work. Now on this one here, they wanted it in simplest radical form. All right, I'm going to do this one real quick so I don't waste your time, and see if you can get it in simplest radical form. Okay, so this is going to be, if we did Pythagorean theorem, what you would get is x squared equals the square root of 4 squared plus 6 squared. Okay, I mean x squared would be 4 squared plus 6 squared, and you would just take the square root of x of both sides, and you would get x equals the square root. This is going to be 16 plus 36, and that is 52. See if you can factor that and write it in simplest radical form, please. Simplify the square root. Okay, if you write out the factors of 52, that's an even number. So I'm going to divide by 2. 2 into 52 is 26. That's an even number. I'm going to divide by 2 again. 2 divided by 26 divided by 2 is 13. You circle the primes. Okay, can't break up 2, 2, or 13. So square root of 52 is the equivalent of square root of 2 times 2 times 13. And anything multiplied by itself under the square root, you cancel 2 of them, and you bring out 1 of them. So I cancel 2 of the 2's, and then I write 1, 2 outside of the square root. And the only thing left over is the square root of 13. So that would be the answer in simplest radical form. Example 2, a 16-foot ladder rests against the side of the house, and the base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? Okay, if they hadn't given the diagram, we would have to draw it, but they did. They gave us the ladder. They gave us a drawing, but they said the ladder is 16 feet and it's 4 feet away. So what does that look like? Well, basically it looks like this. All right, here's the house. This is the ladder. Okay, this right here is the ladder leaning against the house. And they said it's 4 feet away. Now, their answer choices are not simplest radical form. They are either 1 decimal place or no decimal places. Okay, so this one you would just do on the calculator and round off if you need to. By the way, whenever you see approximately, you may have to round off. All right, please try this one real quick. See if you can solve for x. All right, standard Pythagorean theorem. You go to your right angle. Okay, you go to the side. Wherever the right angle is pointing, the point of the right angle, it's basically pointing at the hypotenuse. So this right here is your hypotenuse. That's always going to be the value of c. That means c squared is going to be 16 squared. A and B, it doesn't matter which is which. I will let the x equal a, and I will let the 4 feet equal b. Okay, so a squared is going to be x squared. B squared is going to be 4 squared. All right, and this time I'm going to do the shortcut just to show you. You can make this 16 if you want, but you could actually leave it alone and just do minus 4 squared on both sides. Cancels here. X squared is going to be 16 squared minus 4 squared. All right, if you want to multiply this out and subtract and get one number, you definitely can do that. The opposite of squaring something is square root. Do that to both sides. Square root of x squared is x. And I am going to do this on the calculator. And I get 15.491, and it kept going. But since our answers are rounded to 1 decimal, what you do is you look at the second decimal. If it's 5 or more, you round it up. So 15.4 rounded up is going to be 15.5. All right, and that is in feet. So 15.5 feet. And that is answer D. Quick question here. The Pythagorean theorem is only true for what type of triangle? That would be a right triangle. Okay, you need a right angle and you need a hypotenuse to do the Pythagorean theorem. Example 3, find the area of an isosceles triangle with side lengths 10, 13, and 13. Okay, I am going to draw this first. Side length 10, 13, and 13. They're all in meters. I'm going to leave that off for now. All right, isosceles triangle, it basically has 2 or at most 3 congruent sides. And they said the side lengths are 10, 13, and 13. So I'm going to make this 13, and I'll make this 13, and I'll make this 10. Now, we're looking to find the area of a triangle. Does anyone remember the area formula for the triangle? Well, that's going to be 1/2 base times height. Now, we don't have a height, but we can draw in a height. So, you start at a vertex, and you go perpendicular to the other side. For the isosceles triangle, the best way to draw the height is in between the 2 sides that are congruent. Okay, so in between the 2 13s, I'm going to draw in a height. And what do we know about a height? What kind of angle does it make with the other side? Well, it makes a right angle. All right. And now, if you look at these 2 triangles, they are actually congruent. All right. If this is a right angle, this is also going to be a right angle right here, because this is a straight line. You go across from your right angle, that's your hypotenuse. You go across from the other right angle, that's also going to be a hypotenuse. And this side here, if you consider this as 2 triangles, this side here is congruent to itself. Okay, this is actually a leg. This part in blue, that's actually a leg. So the one on the left and the one on the right, these 2 triangles are congruent. And how are they congruent? They are congruent by HL, hypotenuse leg. Those triangles are congruent. The one on the left is the same as the one on the right. So that means this base right here is equivalent to this base right here. So I'm going to mark that congruent to that. If the whole thing is 10, Each one of these are going to be half of 10. All right, each one of those are going to be half of 10. And of course, we know that half of 10 is just 5. All right, so this should work every time. You don't have to write all this, but this should work every time for an isosceles triangle. So we have a 5 right here, and we have a 5 right here, and that's 13, and that's 13. And now we can apply the theorem. So if you go down, this is my drawing, and this is their drawing. Okay, and now, what did we say we needed? The height h. Remember, we are looking to find area, which is 1/2 base times height. So we have a base, but we need a height. We can work with one triangle at a time. This is a squared plus b squared equals c squared. Okay, across from your right, we'll just do the one on the left. Across from your right angle, that's always going to be c. All right, c is 13, so c squared is 13 squared. The other two sides are a and b, so a is going to be 5, and h is going to be b. All right, therefore, a squared is going to be 5 squared. B squared is going to be h squared. Okay, you can do the shortcut or multiply it out. 5 times 5 is 25. Plus h squared. 13 times 13 is 169. Okay, the opposite of positive 25 is negative 25. 25 minus 25 cancels. Bring down your h squared. 169 minus 25 is 144. The opposite of squaring something is the square root. So h is just 12. Not the final answer. Okay, we need to do the area. That's what they asked us. So let's see. The height is 12, and the base, the height is always perpendicular to the base. The base is this right here, that's 10. Now we're in business. Area of a triangle is 1/2 times the base times the height. So that's going to be 1/2. The base is 10. And the height is 12. All right, if you have an even number, it's easy to take half of an even number. Half of 10 is 5, and 5 times 12 is 60. The units were in meters, but we did base times height. Meters times meters is meters squared. All right, please pause and try number 5. All right, so you can see we have an isosceles triangle. We have the 18 congruent to the 18. So the hypotenuse matches, and this would be the leg. So hypotenuse, leg, two triangles are congruent. If this is 30, this is going to be half of 30. This is going to be half of 30. What's half of 30? Well, that's just 15. All right, so I'll make it 15 and 15. And then this, of course, right here is going to be your height, h. All right, so use a squared plus b squared equals c squared. All right, across from the right angle, that's always c. That's 18. So c squared is 18 squared. A and B, it doesn't matter. So I will let this equal A. That's going to be your height h. I will let this equal B. All right, I am only working with half this triangle on the right-hand side, not this one. A squared is h squared. And b squared is 15 squared. All right. And I'm going to do the shortcut on this one. I'll just do minus 15 squared on both sides. It cancels here. Bring down your h squared. And that's going to be 18 squared minus 15 squared. The opposite of squaring something is to take the square root. So I'm going to do this whole thing on the calculator. If you want to do this part first and then hit square root, you can do it that way as well. Okay, I get a decimal. So you could use the decimal and round it off, but it's better to only round it off at the end. So square root of h squared is just h. And what happens here, this was 99. I am going to leave it as the square root of 99, just for now. You don't have to do that, okay, but I like my answer very accurate. So I'm going to do that for now. H is the square root of 99. And let's see, where do I have room here? I'll make room underneath. All right, so area we said is 1/2 base times height. So that's going to be 1/2. And the base was right here. That was 30. And the height is radical 99. All right, so this is going to be on the calculator here. Half of 30 is just 15. But we still need the calculator. 15 times radical 99. Rounding off, I get 149.2. Okay, they did not say simplest radical form, so I didn't do it. But the units were in feet. When we did base times height, that was feet times feet. So that's going to be feet squared. All right, so Pythagorean triples. What's a Pythagorean triple? It has to be 3 positive integers, a, b, and c, that satisfy c squared equals a squared plus b squared. Okay, so it's basically the sides of a right triangle. That's a Pythagorean triple, the sides of a right triangle. However, they can't be radicals or fractions or decimals. They have to be 3 positive integers. So here is a chart with some common Pythagorean triples. Okay, the most common one of all time is a 3, 4, 5 right triangle. Okay, the longest side is always going to be your hypotenuse. So the 5 is going to be your hypotenuse. And if you multiply each one of these sides by a number other than 0 or negative, you're going to get another right triangle. Okay? And if you multiply it by a positive integer, you're going to get a Pythagorean triple. So if you take 3, 4, 5, and you do times 2, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. All right, over here, they basically did times 10. 3 times 10 is 30, 4 times 10 is 40, 5 times 10 is 50. All right, so these are all spin-offs of the 3, 4, 5. Now, there's other ones as well. I'm not going to make you memorize them, but 3, 4, 5 you should know. That's the most common. There's also a 5, 12, 13. Okay, there's an 8, 15, 17. And there's a 7, 24, 25. But in all the cases, the longest one is the hypotenuse. You multiply each one by the same number, and you'll get another one. Like right here, they just did times 2, and they got this. If you do times 3, you'll get that. And same with the other ones as well. So those are your Pythagorean triples. Example 4. Find the length of the hypotenuse of the right triangle. Let's take a look. Now on this one here, of course, we can use Pythagorean theorem. But let's try to use one of the triples. Okay, we have a 10 and a 24, and the hypotenuse is x. We don't know it. Okay, let's see if we have multiples of 10 and 24. Well, if you look at the original 5, 12, 13, you got a 10, 24, 26 right here. So how do you get from this to this? Well, you start with 5, 12, 13, and you do times 2. So let's do that. So these are the side lengths, 5, 12, 13. And we have 10 and 24. Well, let's see. If we take the 5 and we do times 2, we're going to get 10. All right, this is a dash, not a minus sign. And if we do 12 times 2, we're going to get 24. All right, so we have the 10, we have the 24. How do we get the x? Well, we just do 13 times 2. And that's going to be 26. All right, so we did times 2 on each one and got the 26. In case you didn't see it, the 24 was 12 times 2. The 10 is 5 times 2. And so this one is going to be 13 times 2. All right, so x is just 26. We started with 12, 5, and 13, and we just did times 2 on each one to get the x. All right, see if you can get x right here. Use the 3, 4, 5. See if you can find the multiples. Well, across from the right angle is the hypotenuse. That's the longest one. So 9 is the shortest. How do we get from 3 to 9? Well, 9 is the same as 3 times 3. All right. So we use the 3. And 12 is the same as 4 times 3. So we use the 4. Finally, the last one is just going to be 5 times 3. So that equals 15. All right, we used 3, 4, 5, and we multiplied each one of them times 3. All right, see if you can do number 8 and use 7, 24, 25. All right, the shortest side is 14. How do we get from 7 to 14? Well, that's going to be 7 times 2. All right, next one up, the 24. How do we get from 24 to 48? Well, that's 24 times 2. Notice each time we did times 2. So now just take the last one, 25, and do times 2. What do you get? 50. So if you know the Pythagorean triple, it's a shortcut. You don't have to use a squared plus b squared equals c squared. That's the idea.